Beginning into thermodynamics, or in this case thermochemistry, we're going to talk about how heat energy affects or interacts with matter. And to begin with, first we're going to talk about specific heat. Now, specific heat is the amount of energy needed to raise the temperature of a substance 1 degree Celsius. So if I got 1 gram of a substance, doesn't matter what substance it is, it's going to need energy in order to raise its temperature. Not all substances absorb the same amount of heat. Different materials will absorb different amounts of heat before it changes its temperature. Metals tend to have a low specific heat, meaning they're going to raise their temperature with a small amount of energy, whereas something like water is going to require a great deal of energy relatively in order to raise its temperature. A very similar idea is what's called a calorie. Now, the difference between a calorie and specific heat is pretty much what substance we're dealing with. Specific heat is for any substance. A calorie is the amount of energy needed to raise the temperature of water 1 degree Celsius. So, energy needed to raise the temperature of water 1 degree Celsius. These two definitions are practically the same, it's just it varies in what substance we're talking about. Specific heat is for any given substance. A calorie is specifically for water. Now, looking at the definition of specific heat, now how much energy a substance needs in order to raise its temperature depends on a few variables. First, it depends on the mass. How much mass is there of this substance? If there's a lot of the substance, it's going to take a lot more energy in comparison to if there was very little of it. So the more mass there is, the more energy that's needed. So more mass needs more energy. And vice versa. If there's a small amount of mass, there's going to be less energy needed. How much energy is needed also depends on how much of a temperature change are we talking. So to the temperature itself. If you want to change the temperature a great deal, you'll need more energy. So if you want to change the temperature a small amount, you'll need a less amount of energy. So larger temperature changes require more energy. And then we come to specific heat itself. Now, specific heat is a constant for individual substances. It's specific for a specific substance. So this is a constant value per substance. It's a constant value for a substance. So these variables, they all have a relationship with each other. They are all proportional to the amount of energy that's going to be required. The more mass you have, the more energy required. The more specific heat a substance has, the more energy is going to be needed to heat it. The higher the temperature change, or the more the temperature change, the more energy is going to be needed to change it. So these variables are all proportional to energy. Since they're all proportional, that gives us a direct relationship to energy. So our formula for this is going to be Q equals mc delta T, or MCAT. So Q is heat energy. This value can be positive and it also can be negative. Positive means absorbed energy. Negative means released energy. So that basically means absorbed heats up, released cools down. So you can see positive and negative values for heat energy. Heat energy will be measured in joules, which will be symbolized with a J. You can also do kilojoules if you have a lot of energy. M is mass. Typically, it's going to be measured in grams. You may also see it in kilograms. C is your specific heat constant. May also be referred to as heat capacity. This one will be in joules per gram degrees Celsius. May also see it in joules per gram Kelvin, which is the same. These two are the same thing. There's no need to convert. May also see it in kilojoules per kilogram degrees Celsius. But the typical one you will see is this joules per gram degrees Celsius. And then lastly, we got delta T. Now there's two parts to this one, delta. Delta means change in. So a little subnote at the bottom, delta means change in. So in this case, it means change in temperature. Change in temperature. Well, how do we find the change in temperature? Well, that's easy. You take the final temperature, or the temperature final, and you subtract the initial temperature, or the starting temperature. When you subtract the initial from the final temperature, that gives you the change in temperature. So it gives you the change in temperature. And that change in temperature is what you'll plug into your formula. And you'll see temperature measured in degrees Celsius. You may see it in degrees Fahrenheit, but typically it's going to be in degrees Celsius. Just had a few little more notes. We said C was a specific heat constant. A constant means it's a value that doesn't change. So all these substances will have different specific heats. Some of them you may end up memorizing, some of them you may just know by heart because you use it so much. These values aren't going to change for their substance. Water, for example, has a specific heat of 4.184 joules per gram degrees Celsius. That means in order to change 1 gram of water 1 degree Celsius, you need 4.184 joules. In comparison to that, we have iron. Iron has a much lower specific heat. It is 0.44 joules per gram degrees Celsius. Iron doesn't require near as much energy to change its temperature as water does. That's why cooking materials are typically made of metals. It doesn't take much energy to heat them up, and they can also hold a lot of energy before they do melt. Water, on the other hand, makes a good coolant. It can absorb a lot of energy before it heats up, so it keeps the system cool. For any other specific heats, you just want to take a look at a specific heat chart. Now on these charts, one thing you got to keep in mind is the temperature it's set at and the unit of that specific heat capacity. If your problem is in joules and grams and Celsius, then you want your specific heat capacity unit to be joules per gram degrees Celsius. So if it were joules per gram degree Fahrenheit, you would have to convert that Fahrenheit to Celsius. So with all that said, the best way to learn how to do specific heat is just to practice doing problems. So let's work out a couple of problems and see what we can figure out. So our first problem is the temperature of 250 milliliters of water changed from 24.5 degrees Celsius to 30.5 degrees Celsius. How much heat did this sample absorb? Just like any other problem, you want to pick out your given information. Since I know I'm doing specific heat, I'm going to go ahead and set up my variables for specific heat, which is Q, M, C, and delta T. Now let's pick out our variables. First one I see is 250 milliliters of water. Well, that's a volume. Milliliters is a volume. I don't have volume in my problem. I have a mass. So what do I do with volume? Well, if you don't know the conversion for volume of water to grams, it's pretty simple. For water, 1 milliliter equals 1 gram. So with that in mind, if 1 milliliter equals 1 gram, then 250 milliliters equals 250 grams. It's a one-to-one conversion factor. So however many milliliters of water you have, that's how many grams of water you have. So I got 250 grams of water, and the temperature changed from 24.5 to 30.5. I have a temperature variable in my formula, but it's only change in temperature. But how do we find the change in temperature? Well, the change in temperature is temperature final minus temperature initial. So the final is what it rises to, that's 30.5. The initial is what it started at, it's 24.5. We subtract those two values, well, it changed by 6. So the change in temperature is 6 degrees Celsius. How much heat did this sample absorb? That means I'm looking for Q. How many joules did it absorb? I'm missing a variable, C. What's C? Well, C is specific heat of my substance. This substance is water, so I'd go to a chart or I'd look in my notes for the specific heat of water. So earlier we said water is 4.184 joules per gram degree Celsius. Now I got all my variables. I write my formula. My formula is Q equals MCAT, or Q equals MC delta T. So Q is what I'm looking for, so that's X. M is 250 for the mass. C is 4.184 for specific heat. And my temperature change, we said, was 6 degrees. Now to solve this out, all we got to do is multiply. So 250 times 4.184 times 6. So X equals 6,276. 6,276 what? Well, I was looking for Q. Q is heat energy. Heat energy is measured in joules, so that is joules. Some teachers may want you to report it as kilojoules. So in that event, move your decimal 3 times to the left, so 1, 2, 3. Or you could also divide by 1,000. So you could also report this as 6.276 kilojoules. And if you're having to round up, you could also report it as 6.3 kilojoules. Depends on your teacher, I suppose. So next one says, how much heat in kilojoules has to be removed from 450 grams of water to lower its temperature from 30 degrees Celsius to 10 degrees Celsius? Keywords are very important in this one. We're removing heat energy to lower its temperature. If you're lowering your temperature, your Q, your heat energy, is negative. So make sure your answer is negative for this one. So let's pick out our variables. Got Q, MC, and delta T. So how much heat in kilojoules? So I'm looking for Q in kilojoules this time. It's specified. I got 450 grams of water. So 450 grams of water to lower its temperature from 30 degrees to 10 degrees. So my delta T is the final. Final this time is 10 minus the initial, which is 30. So that's going to be a temperature change of negative 20 degrees Celsius. And then we got our specific heat constant. We're dealing with water, so it's 4.184 joules per gram degrees Celsius. So we set up our formula. Q equals MC delta T, or MCAT. Q is X, that's what I'm looking for. M is 450. C is once again 4.184. temperature change is negative 20. So what is X? So 450 times 4.184 times negative 20, we get negative 37,656. Now this is in joules currently. It's in joules because our specific heat was in joules. The problem wants us to report it in kilojoules, so we got to do that conversion. So all I got to do is divide this by 1,000, or I could just move that decimal 3 times. So this is really negative 37.7 kilojoules. And there is our answer. Let's do another. This time we're looking for the specific heat. We're looking for the specific heat of silicone. If it takes 192 joules to raise the temperature of 45 grams of silicone by 6 degrees. So let's pick out our variables first. So what is the specific heat? I'm looking for C. That's going to be in joules per gram degrees Celsius. I got 192 joules of energy. So that's 192 joules. To raise the temperature 45 grams, so that's mass, 45 grams, by 6 degrees Celsius. So it changes by 6 degrees Celsius. This is a change in temperature. No need to find the change in temperature since it gives it to us. Now we can set up our formula MCAT. So Q equals MC delta T. Q is 192. M is 45. C is what I'm looking for. I'm looking for that specific heat. Temperature change is 6. Now I just do a little bit of algebra. So I got 192 equals 45 times 6 is 270. 270 times x is 270x. Divide by the value with x, so 270 cancels out. 192 divided by 270 gives me 0.711, but we need a unit. This was in joules per gram a degree Celsius. Use the units of all your other variables to produce the unit for a specific heat. Alright, let's do one last problem. If the specific heat of lead is 0.128 joules per gram degree Celsius and a 50 gram sample absorbs 850 joules of energy, what will the final temperature be if initially the temperature is 25 degrees Celsius? Alright, so this one's a little bit more challenging, but we can do it. So as always, let's pick out our variables. It says the specific heat of lead is 0.128. So 0.128 joules per gram degree Celsius. We got a 50 gram sample, that's mass. It absorbs 850 joules, that's Q, that's heat energy, 850 joules. What will the final temperature be if initially it's 25 degrees? Alright, so the change in temperature is temperature final minus temperature initial. We're looking for the final, so that's going to be X. We have an initial, so that's 25. So my delta T is X minus 25. So let's plug into our formula. So I got Q equals MC delta T, or MCAT. So Q is 850. M is 50. C is 0.128. And change in temperature we said was X minus 25 because it's final minus initial. I'm looking for the final. I have the initial of 25. So this is X minus 25. Alright, let's knock out some algebra. This looks a little complicated, but it's truly not. So 850 remains 850. 50 times 0.128 gives me 6.4. So I got 6.4 times X minus 25. So I got 850 equals, here's where we distribute. So 6.4 times X is 6.4X. 6.4 times negative 25, 160. Now we add like terms. So plus 160, this cancels out. Plus 160, 850 plus 160 gives me 1010 equals 6.4x. Divide by the value with x, that cancels. So 1010 divided by 6.4 gives me 157.8 degrees Celsius, since we're looking for a temperature. So there is our final answer, or our final temperature rather. So specific heat is just about picking information out of a problem, setting it into your formula, and doing some algebra. Key things to take away is make sure your units match. So make sure your specific heat units match the rest of your problems. If you have specific heat in joules per gram degrees Celsius, your heat energy needs to be in joules. Your mass needs to be in grams. Your temperature needs to be in Celsius. Most specific heats you can look up on a chart. Again, make sure you check the units of the chart. Make sure it's consistent with what you're dealing with. Also remember, if you're losing heat, your energy is negative. If you're gaining heat, your energy is positive. And those signs will make a difference in your answer. It's very important you pay attention to the sign notations. And I hope this video helps. And as always, good luck on your tests.